Okay, 1050. So on the screen, you're currently looking at a couple of notes from 6.7, and these notes were given to you in the PowerPoint that I hope you read over prior to watching this video. 6.7 is talking about systems of equations, so that's what I've titled it. And there are 4 ways to solve systems of equations. So let's underline that, 4 ways to solve systems of equations. The first way, as you know, we can solve anything using guess and check. So here's way 1, guess and check. It's not time efficient, and so we're going to look at that real quickly and then kind of move on from guess and check. The ones that my math lab really focuses on, in addition to your text focusing on, is graphing, substitution, and my personal favorite, elimination. So this is a longer lesson, so it's going to be a little bit longer of a video, so just bear with me, and let's get ready. So the very first example 1, okay? So x plus y, so 2 numbers, x plus y equal 5 when you add them. And when you subtract those same numbers, x minus y, let's say it equals 1. So you can probably guess that. I need 2 numbers that add to get 5 and subtract to get 1. So if you start thinking what numbers add to get 5, for example, 4 and 1. 4 plus 1 does give me 5. But according to the second equation, when you subtract the 2 numbers, you're supposed to get 1. And 4 minus 1, guys, does not equal 1, which means 4 and 1 are not the answer. So we guessed and we checked, and it did not work. You may say 3 and 2. 3 plus 2 does give you 5. You're exactly right. And 3 minus 2 does give you 1. So you're exactly right. 3 and 2 are the answers, but you have to specify which variable is which. And those of you can already tell x equals 3 and y equals 2. Why? 3 plus 2 is 5, and 3 minus 2 equals 1. So your answer would be 3 is x and y is 2. A lot of times my math lab and math teachers will ask you to write your answer as an ordered pair. So your ordered pair would be 3, 2. Okay? X is 3, y is 2. So that's an example of guess and check. Okay? That's all we're going to do with guess and check. Let's move on. Example number 2. Let me give you y equals, let's do this. Let me come up with 1. Y equals 1/3 x minus 3. And y equals negative x plus 1. Okay? So hopefully you recognize from the last section that both of these equations, both of these linear equations, are written in SIF. And what does SIF stand for? If you remember from the last section, it stands for slope-intercept form. And just to be reminded, slope-intercept form is y equals mx plus b. You're exactly right. Okay, good. And so if they're in slope-intercept form, guys, I can graph them. And if you remember, method number 2, if I scroll back, was solving by graphing. So that's exactly what I'm going to do. I'm going to solve the system of equations by graphing, okay? And so if I come over here and I've tried to do graph paper as the background again, okay? So let's take a look at line 1, and I'll do line 1 in orange. Okay, so line 1 will be in orange. Line 1 has a y-intercept of negative 3. So I go down 1, 2, 3, put my y-intercept. And a slope of positive 1/3, which means I go up 1 and over 3. I go up 1 and I go over 3. And I could continue going if I'd like. I could also go down 1 and over 3. Hopefully you know you don't need 4 points to graph a line. You only need 2. But I tried to give you a pretty good extended line there, guys. Okay? And so I'm going to go back with the black and just make my coordinate plane just a little bit bigger. Okay? So there's a longer coordinate plane. This is your x-axis and this is your y-axis. So you have a good picture. Okay. So now I'm going to go to line 2 in pink. Line 2's y-intercept is 1, so I'm going to start at 1. The slope is an imaginary negative 1 in front. Okay, so we've got Up 1 and left 1, up 1 and left 1 because it's negative slope. Or we could go down and right, down and right, down and right, down and right. And continue drawing these lines. And so I'm going to connect your ordered pairs. Okay. And I hope you see that these two lines intersect. Okay. They intersect at this magical point right here. Here's the point of intersection. And that point, gang, if I take a look at it, is 1, 2, 3, negative 2. So that ordered pair is 3, negative 2. The two lines meet at 3, negative 2, which means the solution is 3, negative 2. So if you're really good at graphing, you may like to solve all systems of equations by graphing. But remember, to solve by graphing, most kids like both lines to be in slope-intercept form, okay? So let me give you an example. Let's move on, okay? Number 3, let me give you an example of substitution, okay? So I'm pulling up a problem on my other computer. Thank you for bearing with me through this time. Okay, so I'm going to actually give you 2 examples here. So let's do part A, or problem A, and then we'll do problem B. So let's say y equals 4. That's equation 1. And then 2x plus 3y equals 10. So guys, do you realize that y simply equals 4? I flat out tell you that y equals 4. So everywhere you see y, you can plug in a 4. So focus on the other equation. So in that equation, we have 2x plus 3. Oh, goodness, there's a y. What am I going to plug in or substitute? That's why it's called substitution. What am I going to substitute? I'm going to substitute in a 4, aka plug in a 4, equals 10. And guys, you know how to solve from here. This is 2x plus 12 equals 10. And I know you know how to solve this. Let's get x by itself. So let's subtract 12 on both sides. We get 2x, 12's cross out, equals negative 2. You guessed it, divide by 2, x equals negative 1. And so if you know x and you know y, you know the magical ordered pair where these two lines cross, aka the solution point. And the solution point is negative 1 because that's your x, and 4 is your y. So that's example A, solving using substitution. Okay, so now let's do example B, still solving using substitution. So this is going to be a little bit more challenging. Let's do y equals 6x minus 11 and negative 2x minus 3y equals negative 7. Okay, so this time, guys, in the first example up there in A, y just equaled negative 4. So we plugged in, or not negative 4, y equaled 4. So we plugged in 4. Y now equals 6x minus 11. So everywhere I see a y, I'm going to plug in 6x minus 11. So focusing on the other equation, the one that's not highlighted, that equation starts with a negative 2x minus, oh goodness, there's a 3, but then there's the y. So what am I going to plug into y? 6x minus 11. Make sure you're using parentheses. Equals negative 7. Okay. So now let's clean this up. So negative 2x stays negative 2x. We're going to distribute negative 3. So negative 3 times 6x is negative 18x. Negative 3 times a negative 11 is a positive 33. Be careful, guys. Equals negative 7. Combine like terms. Negative 2x minus 18 more x's is a negative 20x. Plus 33 equals negative 7. And y'all know how to solve from here. Subtract 33 on both sides of your equation. We get negative 20x. 33 minus 33 is 0. Equals negative 40. Divide by negative 20. Divide by negative 20. and x equals a positive 2. Okay, so we have x, but guys, we don't have y. Like, we still don't know what y is. And you know, in order to write an ordered pair, we have to have an x and a y. But if you go back up to what I highlighted, okay, right here, y is 6x minus 11. So y equals 6 times x. Well, what did you just tell me x was? X clearly equals 2. So what am I going to plug into x? I'm going to plug in a 2 minus 11. Y equals 6 times 2. 6 times 2 we know is 12 minus 11. So y equals 12 minus 11, and 12 minus 11 is 1. So we now know y. Y is 1. So what's the ordered pair? The ordered pair is 2, 1. And so one thing I do not like about this problem, or both of these examples, is that both of these examples already have y by itself. And you may say, well, that means we have to have y by itself. No, we do not. So here is letter choice C, or not letter choice C, but example C, and then we'll be done. So let's do x equals negative 3y plus 1. And then let's do negative 3x minus 3y equals negative 15. Okay? So what variable is by itself? X is by itself, which means, unlike the last two, the first example, we knew what y was. Y was isolated. In the second example, we knew what y was. Y was 6x minus 11 because y was isolated. In example C, what variable is isolated? X is isolated. X is negative 3y plus 1. So we're going to plug in this equation, or this expression, into x, gang. So take a look. Negative 3, oh God, there's x. Plug in negative 3y plus 1 minus 3y equals negative 15. Okay, again, I was focusing on the other equation. If I take a look and I distribute, I have negative 9y minus 3 minus 3 more y's equals negative 15. Combine like terms, negative 9y minus 3y is negative 12y minus 3 equals negative 15. And y'all know how to solve this from here. Add 3, negative 12y equals a negative 12. Divide by negative 12, divide by negative 12. Y equals 1, guys. Okay? And again, this time we know y, but you and I both know in order to write an ordered pair, we have to have an x and a y. Y we said was 1, which means I need to go plug my y in to find my x. So go back to that highlighted region. X is negative 3y plus 1. So x is negative 3y. What the heck is y? 1 plus 1. X equals negative 3 plus 1. And you and I both know that negative 3 plus 1 is negative 2. So x is negative 2. So there is my magical ordered pair. So all of these boxes, these ordered pairs, if I was to graph them, if I was to go back up to this method, if I was to graph these lines, these ordered pairs are where these two lines intersect. Okay? And the last method, so this would be method 4. Yep. Method 4 is solve by elimination. Okay. So before we get there, let's double check something. You can always use guess and check. It's just not smart to use guess and check because it may take forever. When is it easy to solve by graphing? It's easy to solve by graphing if both lines can be written in slope-intercept form easily, or if they're already written in slope-intercept form. So if they're written in slope-intercept form, by golly, let's graph them. When do we use substitution? When we have a variable isolated. So in A, y was isolated. In B, y was isolated. In C, x was isolated. So when you have a variable isolated, substitution is easier. Okay? And so now we're going to go on to elimination. Okay? So let me give you an elimination problem, and I prefer this method. At least I did when I was learning algebra for the first time. So let me give you this problem. To eliminate means to get rid of. So we're just going to dig right into it. I'll give you 2 examples. Negative 4x minus 2y equals negative 12. And 4x plus 8y equals negative 24. So let's take a look. Guys, if you were to combine these 2 equations, okay, if you were to combine these 2 equations, negative 4x plus 4x, these 2 things would cancel out. Negative 4x and a positive 4x eliminate because negative 4x plus 4x is 0x and 0x is 0, okay? So those are gone. Negative 2y plus 8y is 6y. And negative 12 plus a negative 24 is a negative 36. Well, guys, that's easy to solve. Divide by 6, divide by 6. Y equals negative 6. So again, we know y. Y is negative 6, but we're missing our x. So you get to pick. You can plug into the top equation or you can plug into the bottom equation. But if you haven't learned by now, you have to plug in your first variable to find your second variable. So if I look at that first equation, we had negative 4x minus 2y equals negative 12. So negative 4x minus 2y. What is y? Negative 6 equals negative 12. Negative 4x plus 12 equals negative 12. Okay, let's finish it. Subtract 12 on both sides. Negative 4x equals negative 24. Divide by negative 4, divide by negative 4, and x also equals negative 6. Okay, that does not mean, guys, that x and y will always be the same number. That's actually probably not the best example for me to give you because it is only a coincidence that x and y were exactly the same. Okay, so that one was an easy example because the negative 4x and the positive 4x automatically eliminated. Now let's go to B. So if I look at B, 7x plus 2y equals 24. And 8x plus 2y equals 30. Let's take a look at these 2. Well, guys, if you were to combine these 2 equations right now and add them, 7x plus 8x is 15x. 2y plus 2y is 4y. 24 plus 30 is 54. Do you notice that nothing eliminated? Nothing went away. We got rid of absolutely nothing. So that did not help us at all. Okay? Hopefully, you know in order to eliminate, you have to have a positive number and a negative number in order to eliminate, a positive and a negative. So if you take a look, I'm going to underline these 2 2's because you have a positive 2 and a positive 2. In order to eliminate, one of those 2's needs to be negative, which means I need to multiply the entire equation, not just the one side or one number. I need to multiply the entire equation by negative 1, okay? So watch what happens if I get rid of this. I'm not going to change that first equation at all. I'm just going to rewrite it right beside it to stay organized. Just rewriting, guys. If I multiply that second equation by negative 1, negative 1 times 8x is negative 8x. Negative 1 times 2y is negative 2y. Negative 1 times 30 is negative 30. Now let's combine these equations. 7x plus a negative 8x is a negative 1x. 2y plus a negative 2y is 0. It is gone. Those have eliminated. Equals 24 plus a negative 30 is a negative 6. Divide by negative 1, divide by negative 1, x equals a positive 6. So if you haven't realized yet, you have to have an x and a y, your ordered pair. So I know x, I do not know y, so let's go back and plug in x to find y. So 7 x is 6, plus 2y equals 24. That was the original equation. 7 times 6 is 42, plus 2y equals 24. Subtract 42 on both sides, gang. 2y is going to equal, what is that? 24 minus 42, 18. Negative 18. Okay? Divide by 2, y equals negative 9. So go back up here to my ordered pair, negative 9. Okay? So that is 2 solid examples on elimination, 3 solid examples on substitution, and 1 solid example on graphing. So that should be a pretty good start to this. So good luck finishing this